Welcome to the special edition of the Uptime Wind Energy Podcast. I'm your host, Alan Hall, along with co-host Joel Saxum, and we are in Minneapolis for the 2024 American Clean Power with the co-founder of eologix-Ping, Matthew Stead.
Thank you,
Matthew,
Alan.
welcome back.
Thank you. It's great to be here. I actually was here with you a year ago.
Oh, that's right.
Yeah.
In New Orleans.
Yeah.
And so it has been a year since the merger of eologix and Ping.
Yeah,
So a lot has happened over that year's time span.
absolutely.
We should touch upon that. I first want to get your opinion of what this convention has been relative to New Orleans last year, what your thoughts were, what the interfaces have been with your customers. What'd you think?
Yeah, I think industry's growing, fleet's getting older, design issues, serial faults. So every month, every 6 months, every 12 months, there's more and more challenges we're seeing, and I think that was reflected in the discussions we had here.
I think you're getting that it's just being communicated, right?
Yeah.
Like, hey, we have this problem. Can you do to fix it? I sat with someone last night at dinner, and they literally just said, like, I've got this. I want to do this. I want to do that. I want to do that.
Yeah.
Who can do that? I said, well, nobody can do all three, but this company can do this one, this. I said, Ping Eologix can monitor for this, and you can do this for this, and there's some gearbox stuff for that. So people are looking for solutions for their plaguing problems, and I think that is exactly what you said as the fleet ages.
Yeah.
Right? It was before everybody was just kind of like trying to catch up. And now you're getting engineers into places. We do talk to a lot of people that are hiring engineers. Hey, this person's brand new to our team.
Yeah.
Whether it's from the insurance side, asset owner side, even ISPs. I talked to an ISP. Hey, we got a great new blade engineer to help bolster our ability to repair blades. It's like, oh, that's fantastic for you guys as well. So more engineering help, and that's just giving more bandwidth to basically the stakeholders in the industry to solve these problems.
Yeah. And we're all here to help.
Yeah, for sure.
All here to help.
Right.
This is the place for it.
We have seen a lot of engineers this week with specific problems. Mostly blade problems, occasionally bearing problems, even though it depends on the platform. There's some platform with a lot of bearing issues at the moment. And we have seen a narrowing down of the possible solution companies. And that's what I noticed this week. The number of drone companies has really diminished. Robot companies way down. It's drones.
Yeah.
Pretty much all that's left, right? Because they're so dominant in that market space. And then when it comes to acoustic sensing, remote sensing, continuous monitoring, that's eologix-Ping at the minute.
Yeah.
Because of the really it gets down to cost, right? And what the product can do. So you packed a huge amount of information in this little tiny package that doesn't require any wiring.
Yeah.
And that just has opened up the opportunities for eologix-Ping. I think there's everybody was talking to what can we do? And when they come to our booth, we say, well, eologix-Ping has the most cost-efficient, readily adaptable, on-the-go product. Just stick it on and go.
Exactly.
And, which is a game changer, right? So the continuous monitoring systems that we're seeing a year ago that were sort of these big monster boxes with the wires everywhere.
Yeah.
They're essentially gone.
They're for engineering projects.
They are, and
Right, you're
R&D,
not going to roll that out fleet wide.
Root cause,
Yeah, because at the end of the day, this is what we need to be able to do. We need to enable the guys in the O&M building to know what they need to do and prioritize. So, like the lightning strike, right? I don't need to know every bit of metadata about that. I need to know which turbine got hit.
Did I get hit?
Go
Which
look
one?
at it. Is there an issue here? Go look, because at the end of the day, every CMS system tells you at one point in time, go look at the turbine. So if you can do that in the most cost-efficient way, that's the answer.
Well, even the number of engineers that were here, when we talked to them, and how many assets do you have? How many turbines do you have? Well, we have thousands. Well, how many blade engineers do you have? 2.
Not enough.
There is no way you're going to be able to monitor that many turbines without having a tool.
Yeah.
There's no way.
Yeah, too much data.
Too much data, not enough simplicity to it, and you can't quick scan, which is the problem I see that eologix-Ping has fixed, is the quick scan.
Yeah.
That,
what's the hot list? What's the top 10%? What's the top 20%?
Yeah, you got to get to that list really quickly every morning.
And
you got to take a look.
And you can scale an install on a wind farm in a day. Like the way I look at that is like I could, if I got my shipment of ping sensors, right, of the acoustic ones, and I had, here, boys, put this in the back of your truck and go put this on every tower we have out there. Okay, they're done at the end of the day.
Yeah.
And all of those turbines are now monitored. Whereas if you have to install, get up in the blades and this and that, it said the ability to scale up the monitoring effort is not there.
Yeah.
Right.
And that's where we started. So I think when I founded the business, I didn't try and design a product and then try and sell it. I spoke to the customers.
Yeah.
What can you afford? What are your challenges? What do you need?
Yeah.
And then we designed a product to suit that. So.
And that's the way it should be, right?
Yeah, it should be.
That's a huge problem. Okay. So this is a conversation I have regularly. I'm a bit plugged in some of the VC world and the tech world in Houston. And there's people that go to these places, like Greentown Labs, the Ion and stuff, that walk in there and just say like, hey, wait a minute. Do you have basically a development partner? Have you talked with someone? You know, instead of breezing by a barroom conversation of primary market research, are you actually engaged with these clients and solving the specific problems they have? Otherwise, you're making a solution for a problem that doesn't exist.
It doesn't work.
Yeah, it doesn't work that way.
Yeah. So I'm really pleased that you're relaying what we set out to do.
Yes.
It's been worth the effort. It's been worth the effort.
And I took that tour along with Joel. If you've been listening to the podcast very long over the last month or so, you've heard about our travel log of going through West Texas and up through Oklahoma and looking at all kinds of turbines.
Yep.
There are problems everywhere. Cranes are out right now, fixing blades. There's a lot of pitch bearing issues. There's a lot of structural issues inside. And when we had stopped to talk to the OEM supervisors and the managers of those sites, they're saying, hey, we have so many problems we can't monitor it, and some of them we just need to monitor. We just going to have to put a monitor on, and they're looking at solutions. They're trying to figure out how to monitor 100 turbines that have some sort of internal blade issue that they know of. How are they going to do that? Well, either you're going to send a technician around to do that every couple of weeks, which just kills your technician time.
Well, they're already killed. Yeah.
They're already stretched.
Right? You're going to have to bring in some outside crew to go do it. Super expensive.
Yeah.
Or you're going to put some sort of continuous monitoring system in. Now, when we stopped at all of those offices, we said, well, the internal blade monitor from eologix-Ping is the quick solution because it does so much, and everybody is just sort of mind blown. There's no wiring. Do you want to describe how that system works?
So the in-blade one, we've got two parts to it: the listening sensor, and then we've got a kinetic power supply. That's it. You plug them together, turns on, it's got all its comms, that's it. And it's all on the closeout panel.
And that doesn't even talk to the SCADA system in the turbine.
No.
It's a completely separate...
Each blade is separately talking through cellular comms back to the cloud. So even each blade doesn't talk to each other because there's no wires between each blade. So each system is one per blade.
So you're solving the cybersecurity issues there too?
Yeah.
Because there is none.
Oh, yeah, there's no connection to the tower. It bolts to the closeout panel.
Well, yeah.
Right, but we're talking about a couple of bolts to a closeout panel versus all kinds of wiring.
Yeah, there's no
light.
Yeah, we don't
Power.
no power coming from the hub. You don't have to get past the slip ring, get past the pitch bearing, none of that stuff.
Yeah, and I think that's going to be the solution we see across the middle of the United States this summer. And as everybody gets used to the fact of we need to go monitor, we need to be spending a little bit of money to go do it. Not a lot of money, but a little bit of money to go do this. The eologix-Ping is the quick, simple way to get there. And let's go move outside of the internal inspection where we're getting the outside of the blade, things you can kind of visually see. We've been using, WeatherGuard has been using the eologix-Ping lightning detection system with some of our customers to detect lightning strikes. So they have strike tape product on. We want to show them they're taking strikes and just record and monitor it.
No damage.
Right. We want to show that there's no damage. And the key to that system, which is working so well and customers love, is the same thing with the internal sensor. Is it's so easy to see it.
Yeah.
It doesn't take really any training at all. You just open your laptop, look at the screen. It'll tell you if it took a strike. It actually sends you an email. It says, hey, you've been struck. And the added feature now, the new feature on the lightning side is what?
So now we correlate when there's a lightning event, determined from our sensor. We know the tower's been struck. Now we correlate X weather data. So X weather is recording the polarity, cloud to ground, and so I've got killer amps. So now we can correlate a real event with the X-weather data.
And we had a real life situation with that system and some of these horrible Oklahoma storms. They had a recent storm just west of Oklahoma City, and if everybody remembers back, there was tornadoes and all kinds of horrible things from that storm. One of the things that happened there also was they had essentially all the lightning strikes in that part of Oklahoma were positive lightning strikes. And they were huge. 100 kiloamps each. So the turbines with strike tape were getting hit with like 140, 160 kiloamp strikes. Those are big strikes in the United States, and they were all positive. And positive strikes tend to be the ones that damage the blades.
Absolutely.
Those are the ones that most likely damage blades. So the Ping unit picked them up every time. Every time. On top of it, it was picking up, we had some notifications of this turbine got struck, but this one also had a leader on it, which was a couple hundred amps. So we picked up the really high one, and we picked up ones that were under 500 amps to a turbine. So it alerted us to that. So now we have a better understanding of what has happened out in the real world, because what did the operator do? They sent technicians out to the turbines that were struck.
Not doing a random inspection over a field. Not knowing which ones to inspect, which one got hit.
Some of these farms, as Joel knows, we drove around them, are 10, 20, 30, 40
It took an hour to drive from one end to the other. I mean, you'll burn up a technician real quick their whole day just looking at turbines. So if you have a hit list, like say in the morning, hey, turbine 4, 7, 10, 12, and 6 got hit last night in that storm. Go look at them. Perfect. Dun. That's easy.
Rather than spending the whole day driving around.
Yeah.
These guys are flat out. The industry is stretched for resources. So
they're all fixing pitch bearings and main bearings, right? So they don't have time to be running around looking at blades. They got other things to do.
Making their life easy.
Right. Yeah. So the acoustic piece, which is the brain, the heart of the eologix-Ping system, that has evolved over time. So the first generation of the acoustics is, from the software side, it's gotten a lot smarter since.
Absolutely.
Scary smart. So inside that little acoustic sensor, if you see it, if you look at the base of a tower that has a ping sensor on it, it's pretty easy to pick out. Inside that black Death Star looking piece, there's microphones in there.
There's 6 actually.
There's 6 microphones in there. And there's a microprocessor.
Exactly.
And it's about the size of a deck of cards. Roughly. So in there is a lot of processing power, though. So the understanding of what's happening with the blade isn't happening remotely. It's actually happening on
the tower.
And that software has evolved because you've been on so many turbines all over the world. You now have an understanding like how a Siemens turbine performs and what noise it makes and what it means. You have understanding what a GE or an LM blade makes versus a TPI blade makes. They all make slightly different noises with different problems. So if you buy that system now, you have all that history already built into the acoustic sensor.
We're approaching 1,400 towers now under monitoring.
Wow. Okay.
I think a year ago we were about 500, 600.
Okay.
So you're starting to
you see that ramp up happening.
And we're pleased to take orders of another 1,000 today.
POs, booth 434.
We can deliver now, so that's probably the key thing as well.
And the one of the issues that everybody thinks about is like, well, okay, we're in remote Texas. Well, how does this thing connect up? Like, how does it work? If it's not hooked to my SCADA system, do I have to have Ethernet on site? How does that actually work? How is it transmitting data, and where does that data go?
So we're using cellular comms, and we're using like a machine-to-machine comms, which is part of the 4G family. So it's sort of 4G, but it's called LTE-M, which is low power, long range. So actually in the US, we've only ever had one site where we really had challenges on comms, and that one site was near a military facility.
Shocking.
So maybe there was some other
that
stuff
makes
going
sense.
on.
So as long as your cell phone works, your technician's cell phone works, your
actually,
Samsung works.
Our system works even if they don't, because we've got longer range.
Exactly.
Because we're transmitting hundreds of bytes, not voice.
So anywhere in the States, the
Yeah.
continental United States.
Apart from near that military facility.
Yeah.
yeah. No, we're good. We're good. This year we should also be coming out with a satellite version. So if there are any black spots,
You'll have
So is that a
offshore. Yeah.
Offshore? Yeah, I wanted to talk offshore, but the communication bit, Starlink and those kinds of systems, that's the next gen.
Yeah.
Is that already in process?
Yeah. That's this year.
That's this year.
Yeah.
Okay.
Yeah. So we'll have more of a hub and spoke approach. So you'll have a central hub talking to each of our devices, and then that will then
Starlink it up to
or
Elon.
Ethernet or whatever. Yeah.
Okay. Okay.
Yeah. Hopefully not to him personally, but
sometimes he's listening.
he might be listening.
The offshore piece also, because the onshore has been so successful. Obviously, offshore's the next gen, and that's where a lot more risk is in terms of new turbines and new environments that don't have a lot of previous history.
Hey, East Coast U.S. offshore, it's going to be a different animal.
Yeah.
We're seeing everybody start to be worried about it. We talked to an operator, a really big operator that was concerned about that, particularly offshore, and who also was using your system over in Europe to trial it. And what they told us, and you weren't in the room when they told us, is like, hey, the ping works. Everything else we tried doesn't work. It gives us erroneous data, a lot of false positives. We're sending technicians out to check things that don't exist. When we have a ping alert, it's real and it's actionable.
Mm-hmm.
So is that sort of development process that's happened offshore in Europe, is it starting to move towards the United States?
Yeah, absolutely. So, I mean, we also believe in like triangulation, like getting multiple sources of data so that, no false alarms. That's really our aim.
Yeah.
Yeah. So, we're also now measuring on the blade with the eologix on blade, former eologix on blade sensor.
Right.
Now we know exactly how the blade is moving, or through sensoring.
And let's talk through that, because some of these new blades have weird dynamics. GE went through that effort on one of their blades that there were some deflection issues, and they ended up putting some counterweights in basically to solve it.
Yeah.
But we're seeing, because blades get longer and the structure's a little bit different, and the environment, as Joel pointed out, is unique at times, that you need to have a little bit of understanding of how the blades are actually moving in wind, no wind situations, because changes there in the way the blade undulates indicate problems. And there's really no way to do that right now without putting a bunch of strain sensors.
Big time sensors
wide.
on.
Yeah.
Yeah.
So how does that system work then? If I want to understand how my blade is moving, particularly they got a new farm, and I'm thinking like SunZia, right? So SunZia, there's 1,000 turbines out there.
Crazy.
Right, and all those turbines are new. The blades are new. Everything about them is new.
And those turbines don't even have type certificates yet.
No, as we learned. It would be a smart move. That's a pattern energy project, right? So it would be a smart move if I'm pattern, not that I'm pattern, not that they would hire me to do this, but in my head, I'm thinking, well, I just need a monitor to see how things move for a while.
Yeah.
And then I'll understand what good looks like versus problem.
Yeah.
It does make sense, you think, to put some of those eologix-Ping sensors on blade, especially when they're on the ground.
Yeah.
Why would
exactly.
you put them on
That's
there?
the best time to do it. Yeah, for sure.
Right. Just
yeah.
instrument it, put them up, start getting some data. The engineers at Pattern, the blade engineers, are superb.
Yeah.
Right? But they are overworked, and they have a lot on their plate already, and we're going to build the world's largest wind farm, pretty much.
Yeah.
So the workload just got even a little harder. Is that the right approach then from a continuous monitoring standpoint?
Yeah, I mean, that's the direction we're going. We've got one product out there at the moment which talks about pitch misalignment continuously where they need to.
Okay.
But our sensors are able to go, up until about 20% mark, 80% from the root. And we can measure the vibration, so we know what the blade's doing, how it's moving. Yeah, this is the next step for us.
If I was someone who had the new two-piece blades, I would put sensors. I'd put them on either side of the two-piece, the joint.
No comment.
I'd want to know.
No, I think, Joel, you're right, is that it's new technology. It has a little bit of history. That history has shown some weakness in the design, and I know there's been a lot of effort to resolve that. But if I'm buying those blades now,
safeguard yourself.
You want to safeguard myself. It's a lot cheaper to detect it early than to detect it late.
Yeah.
orders of magnitude.
Yeah, absolutely.
Especially you want to make sure if there's something developing, you catch it before your end of warranty period.
Oh gosh, yeah. Once the warranty ends, the
And then-
fight
then-
escalates.
Yeah.
Yeah, the lawyers become involved and it gets ugly. The last piece I want to talk about is the icing sensor. Eologix has an on-blade icing sensor. The Ping unit, the acoustic sensor, can also detect ice. It seems like there's a lot of operators in the United States, Texas, all the way up in Minnesota, Canada, that have icing issues, and they talk about them on a downtime. And we had talked to our care about that too.
Yep. Yeah, I actually spoke with quite a few people here about icing this week. And I think it may have something to do with us being in Minneapolis.
Yep.
Right? So the
Beautiful outside at the moment.
Yeah, it's
but
fantastic.
anyway,
It was a beautiful week. But the people that are here from a stakeholder standpoint, there are, National Grid Renewables is here in town, and Xcel Energy is headquarters is down the street. And so the people that operate in these cold climates are here at this show. So I've heard more talk about icing here than you do normally.
Yeah. I think for us, ice is the core of where we started with the eologix side.
Yep.
Yeah.
Absolutely the core of where we started, but the future is ice and beyond. The damage and the lightning.
Yeah.
That's really
Sure.
where we're going. But
Yeah.
it was where we started. So we're monitoring, we're stopping, we're restarting where it's safe.
Yeah.
And we've got a whole fleet of problems, fleet of sensors there.
So but the fleet of sensors, whether it's the acoustic side, the lightning detection, icing detection, vibration, displacement, like anything that's affecting a blade from an environmental standpoint, basically you're picking up.
Yeah, that's why we want to offer
Everything. It's like holistic environmental monitoring for a
Holistic.
term. Yeah.
blade health
legit.
monitoring.
And the way that the eologix-Ping model is set up right now, the economic model is you choose the things that you need.
Yeah.
You
Don't
turn
need
on
it.
the pieces you need.
Don't need it, don't buy it.
Right. If you're in Southern California, it's not going to snow.
Yeah.
Probably don't need the ice.
Not in Australia.
Or Australia.
I always think it's a bit funny. I'm trying to sell or work with customers around icing, and there's no icing in Australia.
No. But Rosemary has been skiing there.
Yeah, she tells
there
us
is
there's snow.
There is
There is
snow.
snow, yeah.
There's just no turbines there.
Yeah, that's right. Yes. So this has been great to have you visit the United States again, Matthew.
It's great to be here.
And spend some time at American Clean Power. And it's been a tremendous week, I think, for everybody who has participated.
And people that went to the Twins game last night and watched the Twins win.
And our team won.
Yeah.
Thank you.
Yeah, so Matthew, thanks for having on the podcast. How do people reach out and connect with eologix-Ping to get some continuous monitoring on their turbines?
Yeah, just eologix-Ping.com. Yeah. They'll find the right people, and or me personally if you wish.
Okay, wonderful. Cool. There we go. Matthew, thank you so much for being on the podcast.
Thanks, guys.